So we saw that water was special because it had such a high specific heat, which was very lucky for us on Earth. Water is also special for another reason. We said that liquids expand as they are heated. Water does this as well, but only above 4 degrees C. Below 4 degrees C, water actually contracts as it's heated, which is actually, as we'll see, very lucky for fish. So imagine that we had a pond on a warm day. The temperature is well above 4 degrees C, maybe 24 degrees C, say. So the pond is at thermal equilibrium at 24 degrees C. The sun comes up. It starts heating the pond up. As the pond heats, the water expands a little bit, and that expanded water is less dense, and so it floats on top. In the next topic, we'll be looking at the formulas for calculating density, etc. So on a warm day, you end up with a warm layer of water on top of the pond. This is why if you're the first person to go swimming in a swimming pool on a warm summer's day, you'll notice that the top of the water is much warmer than down below, because the warm water is floating on top of the cooler water. Now let's say it's the middle of winter. The pond's cooled down to 4 degrees C, and the atmosphere is a bit cooler than that. Say the atmosphere is at 2 degrees C. So the top of the pond now gets cooled by the atmosphere. The top layer goes down to 2 degrees C. Now, if water behaved like a normal liquid, that 2 degrees C layer would be heavier than the layers below, and so would sink to the bottom. But water's special. Because it's below 4 degrees C, that 2 degrees Celsius layer is actually less dense than the 4 degrees water below. So you actually end up with a cooler layer floating on top. Now this is why ice always forms on the top of the pond, not down the bottom. When the ice is formed, water expands when it freezes, which is why the ice always ends up floating on top. But in most liquids, the ice would actually form at the bottom, because you would have the cooler liquid down the bottom. And in most liquids as well, when the solid is formed, it is more dense than the liquid, and so you get the solid formed down the bottom and staying there. However, with water, you get the ice formed on top, and it stays on top of the pond, and the ice then forms an insulating layer between the cooler atmosphere and the rest of the pond. So the bottom of the pond stays at approximately 4 degrees C through the winter, unless it gets too cold, so that the entire pond very cold winter or a very small pond for that to happen. It would never happen, for example, in the lochs in Scotland, because the quantity of water in those lochs is just so great.